Procedural materials are one of the most powerful features in Blender. Instead of relying on image textures, procedural shaders generate surfaces mathematically using nodes, allowing infinite detail, scalability, and customization without visible repetition. In this tutorial, you'll learn how to build a realistic procedural snow material entirely inside Blender. Split your viewport and open the shader editor. Create a new material and name it appropriately. Make sure you're in rendered mode so you can see your material. Since we'll be using Displacement, you'll need to use the Cycles render engine. Also make sure you have the Node Wrangler add-on activated. The Voronoi texture creates the snowy surface breakup. Use Shift-A to add a Voronoi texture. Select the Voronoi texture and use Ctrl-T to add a texture coordinate and mapping node, and change the texture coordinate node to Object. Use Ctrl-Shift left-click to preview the Voronoi texture. Increase the scale and detail of the Voronoi texture to make a breakup pattern for the snow. Now create subtle snow coloration. Use Shift-A to add a mixed color node after the Voronoi texture. Connect the Voronoi texture distance output to the factor of the mixed color node. Use Ctrl-Shift left-click to view the mixed color node. The Voronoi brightness values now determines where each color appears. Change color A to a slightly gray-blue color. Change color B to a bright white. Change the roughness down to around 0.05. These slight color differences help the snow feel colder and more natural. Connect the mixed color node to the principled shader and the principled shader to the material output. To simulate subsurface scattering, change the subsurface weight to 0.5. Select the Voronoi and mixed color nodes. Use the F key to add a frame and rename it to base. Currently the snow is too smooth, so we need to add some bumpiness to the material. Use Shift-A to add a bump node. Connect the Voronoi distance output to the height input of the bump node. Connect the bump node to the normal input of the principled shader. This converts grayscale texture information to surface detail. Change the distance of the bump node to about 0.1. Then move the bump node into the base frame. For smaller details, use Shift-A to add a noise texture. Connect the mapping node to the vector input of the noise texture. Use Ctrl-Shift left-click to view the noise texture. Then increase the scale and detail of the noise texture. Use Shift-A to add a second bump node. Place the second bump node between the first bump node and the principled shader. Connect the factor of the noise texture into the height of the second bump node. This creates a layered bump detail. Use Ctrl-Shift left-click to view the principled shader. Select the noise texture and second bump node. Use the F key to add a frame and rename it to Snow Details. Now add crystalline ice crack patterns. Use Shift-A to add a second Voronoi texture. Connect the mapping node to the vector of the second Voronoi texture. Use Ctrl-Shift left-click to view the second Voronoi texture. Increase the scale of the second Voronoi texture. This creates tiny crystalline breakup patterns resembling icy snow reflections. Use Shift-A to add a third bump node between the second bump node and the principled shader. Connect the second Voronoi color output to the height of the third bump node. Decrease the strength to around 0.4. This sharper bump creates sparkling icy details. Use Ctrl-Shift left-click to view the principled shader. Select the second Voronoi texture in the third bump node. Use the F key to add a frame and rename it to Cracks Detail. Bump only affects shading, so we'll now add true geometry displacement. Use Shift-A to add a second noise texture. Connect the mapping node to the vector of the second noise texture. Use Ctrl-Shift left-click to view the second noise texture. Increase the scale and detail. Use Shift-A to add a displacement node. Connect the factor of the second noise texture to the height of the displacement node. Connect the displacement node to the displacement input of the material output. This converts the texture into real displacement data. Use Ctrl-Shift left-click to view the principled shader. To enable true displacement, open the Material Properties settings. Change the Displacement Surface setting to Displacement and Bump. Now the geometry actually pushes outward. Change the mid-level and scale of the displacement node as needed. Select the second noise texture and displacement node. Use the F key to add a frame and rename it to Displacement Details. By combining Voronoi textures, layered noise, bump mapping, subsurface scattering, and true displacement inside Blender, you can create a highly realistic procedural snow material that is both flexible and efficient. Because the shader is fully procedural, it can scale infinitely without texture repetition. It can easily be customized for different environments and artistic styles. Thanks for following along with this tutorial. If you found this helpful, please like, comment, and subscribe. Have a good day.